Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And since this is the first recording that I'm doing in 2024, I want to wish everybody a very happy and fulfilling new year. I hope you get a lot of your wishes granted by what will happen this year. And today, what I have for you is about AI and LLMs. As expected, I can't tell that this is a surprise. AI, LLM seem to be on the top of everyone's mind related to tech when we enter 2024. And I think this tells a lot about this year. I think we'll have a lot more conversations on this topic as we move on. And there are many things that we can discuss about, and we definitely plan to discuss about many things related to LLMs. Let me just show you a few articles that came out and that were waiting for me. The new Stack article, 7 Guiding Principles for Working with LLMs. And this is quite an interesting set of ideas related to how to program using LLMs. AWS gives Java, Rust developers with useful tools. You can basically now use Amazon Q, the Gen AI offering, Gen AI, from AWS too, and they have actually Amazon Q code transformation that allows to upgrade, for example, to the latest Java version. So that's pretty interesting. Now, I tried to use Amazon Q, but it didn't work at the moment when I tried to. So yeah. But the most relevant one, and the one that I'd like to focus today, is this one. NIST creates cybersecurity playbook for generative AI. And this is very interesting for a number of reasons, but I think it's very interesting in terms of what it shows. It shows that that LLMs in particular, are still very new in terms of technology, and that there are threats that we don't know how to mitigate or how to fight against. And this is a big, big problem. I think this document is very relevant for anybody who wants to use AI in their platforms, for any organization. So NIST is the National Institute of Standards. I think it's an institute that gives guidance for security, for cybersecurity. We discussed about them in relationship with C++ last year. But today what they did, recently, they published a report laying out in detail the types of cyber attacks that could be aimed at AI systems, as well as possible defenses against them. The agency believes such a report is critical because current defenses against cyber attacks on AI systems are lackluster at a time where AI is increasingly pervading all aspects of life and business. And I like that they show this image. This is about an older hack and I think it was for Tesla cars, for the autopilot. Basically, they were trained to follow the dotted line in order to keep on the right lane. But then a few researchers actually placed deceptive markings on road. They placed post-its on the road, and because the post-its are yellow, the car turned. Or you can basically have the same color as the lines, depending on where you are. And the car turned into the wrong lane. So it was enough to place a few pieces of paper on the road to confuse a highly sophisticated technology, right? And these are the types of things that are very, very difficult to deal with. And let's go through this article on AI business a little bit, and then I'm going to dive into the actual report by NIST. NIST identifies 4 major types of attacks on AI systems. Evasion attacks. These occur after an AI system is deployed, where a user attempts to alter an input to change how the system responds to it. Examples include tampering with road signs to mess with autonomous vehicles. Yeah, so the one that we are seeing, but also it could be something like using a yellow or a green balloon that you play with in order to confuse the semaphore color recognition. So even that works. Poisoning attacks. These occur in the training phase through the introduction of corrupted data. Examples include adding various instances of inappropriate language into conversation records so a chatbot would view them as common use. Maybe you remember there was an AI assistant from Microsoft predating ChatGPT that they launched, and very soon after it was trained by users to answer with conspiracy theories and bad language. So just exposing it to users was enough to make it behave inappropriately. Privacy attacks. These occur during deployment, and there are attempts to learn sensitive information about the AI or the data it was trained on with the goal of misusing it. A bad actor would ask the bot questions and use those answers to reverse engineer the model to find its weak spots. This is actually, when I read about it in the article, it didn't sound so interesting, but in the report it's actually much more interesting, but we'll delve into it in a moment. Abuse attacks. These involve inputting false information into a source from which an AI learns. Different from poisoning attacks, abuse attacks give the AI incorrect information from a legitimate but compromised source to repurpose the AI. So these are a few things a few types of attacks. And then defensive measures to mount include augmenting the training data with adversarial example during training using correct labels, monitoring standard performance metrics of ML models for large degradation in classifier metrics, using data sanitization techniques, and other methods. But even more interesting is if we delve into the actual article, the report by NIST published January 2024. It's called Adversarial Machine Learning, a Taxonomy of Terminology of Attacks and Mitigations. So it basically doesn't claim to describe in detail each attack, but it's more like a classification and a list of terms that you can use in relation with attacks to AIs. And already splits into the types of AIs into predictive and generative. So predictive would be things like image recognition, while generative is LLMs. And it talks about it's full with a lot of jargon, technical jargon. I can say I understand 100% of everything that's here. But I'm going to focus on the generative AI and just go through a few types of attacks. And I have an interesting schema here that shows the types of attacks on the different, let's say, objectives, right? So there are a